All right, let's put those definite integrals to some use here by finding these regions between the curves. Now, before we get started, notice this is graph paper because we are going to be graphing. So I got a couple of disclaimers for you. Here's our first one. In my math lab, the graphs are given. Now here's the big disclaimer, but I expect you to know how to graph. That's the moral of their story. But on your test, you will have to graph like we do in your notes. I want this in your notes, which is why I'm writing. I'm not just giving a verbal disclaimer. That's how important this is. But on your test, you will have to graph like we do in our notes. Have to. Is that what I said? I think so. In our notes. Something along those lines. We're going to graph in our notes, all right? The graphs are given to you in my math lab just because that's one of my math lab's downfalls is the whole graphing thing. So you are going to have to graph. So here's my other little piece of this. That means you should practice graphing your problems from my math lab on your own paper. So you should practice graphing the problems. I think this is what I said. You get the gist. In my math lab on your own paper. That way you practice graphing. I do expect you to know these basic functions, and I do expect you to be able to graph them. We're going to practice some here as we go through our notes. So if there's any part of these that you are struggling with, then tune into that and learn how to graph it, because you are going to have to graph for these problems. All right. Now, this is still my math lab. So here is my second disclaimer. All right. I, of course, will give you small numbers on your test. Something that is reasonable, and the kinds of problems we're going to graph in our notes, reasonable kinds of things on the test, because you're not going to have a quiz over this. It's just straight to a test. However, this is still my math lab. Some of the problems in my math lab may have big numbers. You know, some will have big numbers and some won't. It's my math lab. You just never know. May have big numbers. I'm having to check myself here before I wreck myself to make sure that I'm writing this stuff down. May have big numbers, so you may need a calculator is what I'm trying to get at. However, I do expect you to be able to graph a quadratic, graph a line, graph an absolute value. Some of these basic things that we know how to do, I do expect you to be able to graph those, and those are the kinds of problems that I will be giving you on your test. But I do want to give this disclaimer right here at the beginning of our notes that the problems will be graphed already in my math lab, but you should practice graphing those on your own paper. All right? Okay. So, without further ado, let's jump right into this super awesomeness over here and rock the socks off of it. Area of a region between two curves. Oh my, oh my. Okay, and a curve may be a line, right? A curve is just anything that's on the graph. All right, I'm going to write out this definition and then we're going to put it into play. Suppose f and g are continuous functions with f of x is greater than or equal to g of x on the interval from a to b inclusive. Notice this is a terrible bracket. I'm going to try that again. So a and b are included in this, okay? Then the area of the region bounded by the graph, the area, I forgot my A, of the region bounded by the graph of F and G on this interval from A to B is given by this. Area is equal to the integral from A to B of f of x minus g of x dx. All right, let's talk about this for a minute. First of all, notice that this f function here is greater than or equal to g of x. So f of x, my output for this f function, is higher or greater than my g of x function. So that is something to pay attention to there. All right. Also, my area is the endpoints count. All right. So I'm going from A to B. If f of x here is greater, that tells me I'm going to take my top function minus my bottom function. That's what that says, contrary to what it looked like. Let's try the whole thing over. That's what you're looking at. Remember what we talked about back at the beginning of when we started talking about integration. Your function here, the top is going to be minus the bottom because I have two separate functions, but anything with an integral is the area under the curve, right? That's what we talked about from the very beginning. That was the basics of integration when we did those Riemann sums. So because of that, here again, my area of integration, if I have two separate functions and I want to know what's between them, I'm just going to take the top one minus the bottom. Just that easy. All right? Cool. All right, we're going to get right into that next.